All right, more optimization practice. The background. All right, optimization. Our goal is to figure out either the maximum or the minimum of whatever it is. We're going to use two formulas, use a little bit of substitution, make sure we answer the question. And we're always looking for that stationary point, take the derivative and set it equal to 0. All right, it says the sum of a number and 3 times another number is 12. Their product is a maximum. Find the numbers and the max product. All right, this is a simpler question than we've done. Everything we've done has a box with a circle and it's got the corners cut out of and then it's got a river or whatever. This is just numbers. So let's look at what we got here. Okay. The sum of a number and 3 times another number is 12. That's a little formula, that's a little equation. That would be sum means add, a number could just be x. 3 times another number could be y this time is 12. So we need the sum of x and 3y equals 12. So we're looking at x plus 3y equals 12. It says that their product is a maximum. I'm assuming that means the two numbers. Find the numbers and the maximum product. So maybe we use P for product. I think these are two decent formulas. I think this is good enough. And so if you look at this equation over here, this equation, which has a bunch of numbers and only has 2 variables, we could work with this. We could come up with answers. For example, x could be 0, y could be 4, and that's going to make 12. Nice, that's great. If I use those same numbers over here, the perimeter equals 0 times 4, or not perimeter, the product, and that would be 0. And so 0 and 4, they work fine over here, and they work fine over there, but that's definitely not a maximum. So what we're trying to do is come up with the two numbers that can create this being true and this being as big as possible. So in order to do that, we want to do some sort of substituting. And you pretty much want to think about one of these is going to have a couple variables, and one of these is going to have even more variables. And so we always want to try to, take this in the correct direction. It also says that their product is maximum. If you know what you're trying to make a maximum or a minimum, well, that is what you're trying to take the derivative of to set it equal to 0. So my goal is I want to take the derivative of this. The problem with taking the derivative of that is that there's p's and x's and y's. That's just too much of a mess. And so we're going to need to use this equation to plug it in and get rid of either x or y. Do you want to solve for x over here on the left or solve for y over here on the left? I think that there is an easier choice. X. I agree to that. X would be a little bit easier. If we want to get the x by itself, we just got to subtract 3y on the other side, and that's easy. If we want to get the y by itself, we have to subtract the x and then divide by 3, and then we're getting fractions. And you could do it that way, but it would be easier. minus 3y the other side, x equals 12 minus 3y. And that on its own doesn't look that helpful, but if we take that and we put it into the other side over there, the product is equal to, well, x is equal to 12 minus 3y. So I'm going to replace my x with 12 minus 3y. And then we have another y here. And honestly, that is optimization, right? Like, that is the new stuff that we've learned. From here on out, it's just a little bit of algebra, a little bit of calculus, get your answer, okay? Honestly, this was the part that we struggled with most, was just, okay, we did the optimization, now don't fumble it right here, okay? You always want to think to yourself, is this derivative going to be easy? Could I do a little bit of multiplication or addition and make the derivative easier? When I'm looking at this, I'm noticing that we have a variable times a variable. That's going to need the product rule. The derivative of 1 times the original plus times the derivative. So that's going to be a little bit complicated. Very easily, I can do a distribution, and that's going to just make it look like a polynomial. I'm going to be able to use the power rule, which is much easier. So let's simplify this first. I guess I don't need parentheses anymore. 12y minus 3y squared. And then let's take the derivative. The derivative p in respect to y is equal to 12 minus 6y. I want to find whether this is a maximum or a minimum, so I set this equal to 0. Add 6y, divide by 6, y is equal to 2. All right, that is definitely a piece of an answer, but no guarantee that that is the answer. No guarantee that that's what we're really looking for. So always revisit the question and make sure you've answered it. Find the numbers and the maximum product. We have one of the numbers, okay? A lot of times when I do this optimization, I like these arrows that kind of go back and forth and back and forth. Use this equation to help you with that. Okay, nice derivative. Use this value to go back to the other side. X equals 12 minus 3 times 2. 12 minus 6, 6. And that means that the product, max product, is 6 and 2, 12. Now that is not really a very difficult question. It's also a somewhat interesting thing that we can do, right? There are many, many different ways that you can solve this equation. We saw 0 and 4. You can come up with other ones, right? You can use x equals 1 and y equals 11/3, right? Ew, kind of gross, but it works. The best possible maximum product you can make is if x is 6 and y is 12. And does it work? Of course it does. 6 plus 3 times 2 is equal to 12. 6 plus 6 equals 12. Great. Feel good with that? All right, let's keep on. Let's go a little faster now that we're warmed up. All right, the iconic river question, or fence along a wall question. A rectangular piece of land is bordered on one side by a river. The other 3 sides are enclosed by 300 feet of fencing. What is the maximum area that can be enclosed? This question is about a box, a rectangle. And if you're doing any question about a rectangle, you gotta be getting these right. These rectangle questions are these are the softballs. These are the easy ones. We can think about these as x and y. But this question has the river. And you don't need to build a fence right along a river. I don't think it would work very great in the long run anyways. You can just trust that the river is gonna count as one of your fences, and that's gonna save you some fence, so that you don't have to fence over there. The area equals xy, that's just a length times width formula, and the perimeter equals, normally it would be 2 x's and 2 y's, but for this question it's only 1 x and 2 y's. Now, as of right now, we have AXY, that's 3, PXY, that's 3, that's too many. So one of these will always be just 2 variables, which means one of these areas or perimeters will be capped, will be constant. And the constant capped says 300 feet of fencing, which means our perimeter, 300. That's capped there. That has given us an X and a Y. And when it says the maximum area, that makes me think I need to look at my area and find our stationary points, look for maximums and minimums. So I need to be taking the derivative of this, but with a, x, and y, that's too much. So let's solve and do some substitution. Again, I think it's easiest if we move the 2y so that we don't have to divide by 2, because that's going to make some fractions. So let's just do 300 minus 2y equals x. Substitute that into there. Area equals 300 minus 2y times y. And hopefully we're starting to kind of, you know what, this is actually a very repetitive process of doing the substitution and then doing a little bit of simplification. Area equals 300y minus 2y squared, very similar to our product from the last question. Let's get the derivative of the area in respect to y, which is going to be 300 minus 4y. Set that equal to 0. Add 4 to the other side, or y, and divide by 4. 300 divided by 4 is 75. And so there is our y value. Revisit the question, what is the maximum area? Well, it's not y, and now I want to find the x. Probably can take it back over there to figure it out. 300 minus 2 times 75, which is going to be 300 minus 150, which is going to be 150. In this question, wanted the area. Area equals 75 times 150. That would be 100 times 75 would be 7,500, and another half of that would be 3,750. So that would be 11,000 something. I don't know. Let's just use a calculator, I guess. No heroes. Do the math in your head.
75 times 150.
11,200. We were right there. Again, just to think about this result for a second. It's somewhat interesting. It's also definitely relevant if you are a farmer who's gonna do this. You wanna make sure that you get the most area enclosed by that fence. You could use the same amount of fencing if you just randomly picked, right? Let's say that the farmer said, oh, 300 feet of fencing. What if I just did, 100, 100, 100? That's easy. I'm a stupid farmer. I'll try that. And then the area would be 100 times 100, which would be 10,000. and they'd be missing out on over 1,000 square feet of land enclosed just because they didn't optimize their choice. So this is, somewhat interesting. Also worth pointing out, I guess I should have feet squared on my area. We're doing real life questions.
Yeah.
Okay, let's go a little bit more difficult. Again, we did do this at the very, very first day, but that was when we were first learning it. We probably don't remember too much. An open rectangular box is made by cutting 4 congruent squares from the corners of a piece of cardboard and folding the sides up. That is what we did. We took a square, we chopped some squares out of the corner, we folded them up, and then we said, what's our volume? How do we find the maximum volume? This is much more difficult of a process to create that equation. The cardboard is 12 feet on each side. What are the dimensions of the box with the maximum volume? So I know right away, maximum volume means I want a volume formula that I can take the derivative of. And the volume of our box, if we look at this, we're going to be cutting some number. We might be cutting 2 or 3 or 4, and we need a letter for that. And whatever we cut out of the corners is going to be folded up, and it's going to be our height. So this is going to be our height. I'll put a little h there. And so, all of these are going to be height. But obviously you don't need to write all of those. Our volume will be height, and then whatever is left over in the middle here, it should be a square on the bottom. And so it might be x and x or whatever. Those x's should make the other 2 dimensions. This is our height. This is going to be 1 dimension, and this is going to be our 3rd dimension. And so our volume formula should be an h times 2 x's. And this is honestly a little ugly. Typically we would like it to look a little bit with our now from here, again, we're having that issue. We have 3 letters. We want the derivative of the volume, but then we have x's and h's, and we can't really do the derivative of a bunch of letters at once. And so we need to take one of these and replace it. Normally we can do that by thinking about, we have surface area and volume, and those 2 things are related. But this question hasn't said anything about surface area, which means if we do make a formula for surface area, it's going to have a ton of variables, and it's not really going to help us out. It doesn't say where the surface area is 500 or something like that. It doesn't mention surface area at all, and so I don't think we can use a whole separate equation for this. What it does say is that the cardboard is 12 feet on each side, which is actually so ridiculously huge, but whatever. It's just a very big piece of cardboard, I guess. The cardboard is 12 feet on each side, so we need to incorporate that 12 somewhere. Surely, that's going to be our ticket. Now, 12 is the full side here. Does that get replaced with the x or the h? Not really, right? I mean, this is h, and this is x, and this is h. So 12 is not h, 12 is not x, but 12 is h, x, h. And so if we, that's 2 h's, so if we write it as x plus 2h, here's a nice little formula that we can now, it's only two variables, solve for one, use substitution, finish the question and get to the end. Do you want to solve for x or solve for h? We've done the same process. If we solve for h, we're going to have to divide by 2. Let's not do that. So let's just say that x equals 12 minus 2h by subtracting the 2h to the other side. Let's take that and swap it up. Volume is equal to x squared, which is going to be 12 minus 2h squared times h. And then again, I'm thinking about the derivative. The derivative is going to be, right now, product rule, also chain rule, because I'm going to have to do the product of A times B, and when I'm doing the derivative of A, it's going to be a chain rule. Right now, I don't really want to do that. That seems, oh my God, the spider is back. Were you guys here when the spider was here?
I don't think so.
There's a spider inside the TV. Can you see?
Yeah.
He's our best friend, I guess. Man, we saw him like 2 or 3 weeks ago. Is he eating inside the TV, or does he come out and eat and then go back in? Right? I mean, who knows? Fascinating. Less interesting than optimization, but fascinating. I want to do a bunch of algebra, get this into a polynomial type thing, then I'm just going to use the power rule. So I'm going to go ahead and FOIL this and then distribute an h. So when I FOIL this, that's going to be 144, that's 12 times 12. Let's write it out, because honestly our algebra has cost us points in the past. 144, negative 24h, negative 24h, positive 4h squared. The h's are getting worse and worse. Sorry about that. Which is going to be 144 minus 48h plus 4h squared. And don't forget we have another h as well, which is going to put an extra h on all those terms. 144h minus 48h squared plus 4h cubed. We can take the derivative of this. Derivative of volume with respect to h is going to be 144 minus 48 times 2, 96h. 4 times 3, 12h squared. That was certainly easier than whatever the heck product rule, chain rule would have been. Certainly. Because after we did all that product rule, chain rule, we probably would have had to FOIL that stuff anyways. And now, equal to 0. I'm noticing that we have a little quadratic here. We have h squared, which means I'm looking at 2 h values that I need to solve for. I'm thinking I either need to factor this, quadratic formula this, maybe complete the square, which sounds kind of disgusting, so maybe not complete the square. I'm also noticing factoring is normally the easiest, but these numbers are big for factoring. I'm also thinking maybe I can just divide everything and just make these numbers smaller. Because now that I have this equals 0, if I want, I can just divide the whole problem by 2 and just get rid of all that. I know that all these numbers can be divided by 2, that's for sure. I know that all these numbers can be divided by 4, that's for sure. I know that 12 can divide by 144. I guess the real question is, can 96 be divided by 12? Now, remember, 96 was 48 times 2, right? Is 48 divisible by 12? Yes. So surely 96 also has to be, if it's just twice as big. So we're in good shape. That should make things a lot easier. Let's divide by 12. We're gonna get h squared minus 96 divided by 12 is gonna be 8. Is that right? 5 makes 60, and then 3 more makes 36, and then 60, yes. Minus 8h plus 12 equals 0. Now this is very factorable. Two numbers that multiply to make 12, that add to make negative 8. H minus 6. H minus 2 equals 0. Give me my two h values. H equals 6. H equals 2. Now we did this question before, so theoretically we kind of know what's going on. But we've got these two values for h. H cannot be 6 and 2 at the same time. It can only be one or the other. Okay? So why are we getting two values for h? So this question is able to find not only the maximum value for our volume, but also the minimum value for our volume. Now there's two ways to think about this. One, this is a real life shape, and so just think about it for a second. The second is to use your second derivative and figure out if you're concave up or concave down, meaning if you're concave up, then you have a minimum, or if you're concave down, then you should have a maximum. If we think about this, if our h value is 6, and that means that our h, don't do that, that our h cuts all the way to 6, and then from this direction, cuts all the way to 6. And it's 12 wide to start, and we cut 6 off one side and 6 off the other side. Basically, we just deleted the whole paper, right? So this is a minimum. Again, if you want to use the second derivative to check that, you could. That means that this 2 is our maximum. And that's great. Let's answer the question, what are the dimensions of the box with the maximum volume? H equals 2. That's part of it. We can go back over here, figure out what x is. X equals 12 minus 2 times 2. X equals 12 minus 4. X equals 8. And so that means that our dimensions of our box should be volume equals 8 feet by 8 feet by 2 feet. It asks for the dimensions, not the maximum volume. If we wanted to find the maximum volume, 8 times 8 is 64, times 2 is 128. So not needed, but the max volume is 128 feet cubed. Again, that's the guaranteed maximum. That's how optimization works. All right, how are we doing? How long has this been? About 30 minutes. Okay. On the back, we have 2 questions. The top one is a lot like the quiz that we did, which means relatively valuable. We don't necessarily know how this one works. And question 5 is the hardest one we've done today for sure. If we're 30 minutes in, well then it's taking us 10 minutes per question. So I'm gonna speed it up for this question. This is easier than the last, or I would say easier than the last one we did. So let's see how this goes. An open box with no lid with a square base has a volume of 4 cubic feet. So, here's our box. There we go. You got your box, it's got an open top. What dimensions minimize the surface area? So here I've heard the words volume and surface area. I want to come up with my formula for this. Typically, volume would be length times width times height, but I know that we have a square base, which means whatever the bottom is, it is the length and the width. And the height can be y, so our volume can be x squared y, which is a very common thing for us to do. If we do have 3 variables, then it becomes very complicated very quickly. So that's a very common setup, is a cube on the, or a cube or a rectangle prism with a square bottom. Our surface area is just add up all the different little areas. So we have a square on the bottom, and that square on the bottom is x by x. That is our bottom piece. Typically it would be 2x squared, but we don't have a top, so we just got rid of that top x squared. Then our box has 4 walls, and those 4 walls are x by y. 1, 2, 3, 4, and so we should have x by y. All right, we've got our 2 equations now. One of them has to be capped so that we can kind of get rid of that letter and then solve for one of the other 2 letters. And this one says that our volume is capped at 4 cubic feet. So our volume is 4. That allows us to get rid of the volume, only see x's and y's, and then solve for one of these. Again, if I think about solving this, if I want to solve for the y, I divide by x squared, that should be good. If I want to solve for the x, I have to divide by the y and then square root both sides. And that's going to give me square roots. And honestly, math with square roots kind of sucks. So I'm going to solve for the y. I'm going to say y equals 4 over x squared. Now this is where we ran into a lot of problems on the quiz. We pretty much made it this far. Most of us even did a substitution. And then we just crumbled from here. Now this should be the easy part. A little bit of simplifying, do a derivative, set it equal to 0. And not only that, this almost looks like a polynomial. This almost looks like a very easy derivative. You know, this, very easy derivative. X squared derivative is 2x. This, however, not so easy right now. Looks like I need to do a product rule, okay? Looks like I either need to think about this piece as 4x to the power negative 2, or I need to do a quotient rule, which would be a little silly, but you know, there's a lot going on there. Good news is, I can multiply these 2 things together, and it's not very hard, and it makes it way, way easier. Now let's make sure we know how fraction rules work. 4x times 4 over x squared. This 4x is like a 4x over 1. And when you multiply fractions, you multiply top times top, bottom times bottom. So, you don't put a 4 on the top and a 4 on the bottom. You just go straight across. 4 times 4 is 16. X times nothing is x. Over here, 1 times x squared is x squared. And not only that as simple fraction rules, but also now it becomes very clear that we have 1x on the top, we have 2x's on the bottom, and we are allowed to simplify this. So, we're allowed to take 1x away from the top and 1x away from the bottom. And so, that was a nice walkthrough of fractions. The surface area is equal to x squared plus 4, actually, it was 16 over x. Sorry that I said 4. I need to take the derivative of this, and if you want to be even better, maybe we write it like this. 16x to the negative 1 power, because now the power rule is just going to be so easy for us. The derivative of the surface area in respect to x is 2x. Put the negative 1 out front, negative 16. To take the negative 1 and subtract another, which takes us to negative 2. X squared on the bottom. Set that equal to 0. Okay, now we're in the home stretch. All we have to do is set this equal to 0, get our final answer. We should be okay. Now we need to make sure we respect our fraction rules again, okay? We have 2x minus 16 over x squared. These two things are not in the same fraction. These two things are in different fractions, okay? We can't be crossing stuff off like this. That is a mathematical crime. We should, throw in Guantanamo Bay for that. So, gotta be more careful than that. Since this is equal to 0, let's just move one of those to the other side and just do some multiplying and just not stress about it. So I'm gonna go ahead and add this to the other side. So I'm gonna get 2x equals 16 over x squared. How do I get that x squared out of the bottom? I'm gonna multiply by both sides on x squared. So times x squared times x squared. 2x cubed equals 16. I'm going to divide both sides by 2 and get 8. I'm going to take the cube root of 8, and the cube root of 8 is 2. X equals 2. Okay? Revisit the question, make sure we answered it. What dimensions will minimize the surface area? Oh, the spider's back over there. What dimensions will minimize our surface area? Let's go back over here and figure out what the y should be. Y equals 4 over x squared. Y equals 4 over 4 equals 1. So our dimensions, volume should be 2 feet by 2 feet by 1 foot. 2 by 2 by 1. Of course, if we multiply all that together, it's going to give us 2 times 2 is 4, times 1 is 4. That satisfies our volume there, and this should be the smallest possible surface area. Okay. Oh, still took us 10 minutes. Last question here, and then we'll be done. Now this one is much more difficult, and we're gonna kind of push our brain a little bit here. A sphere has a radius of 6 feet. A sphere, a circle in 3 dimensions. There's our sphere, and it has a radius of 6. What are the dimensions of a cylinder with the greatest volume that can be inscribed in the sphere? So inside of here, we're gonna put a cylinder as big as possible. Now that might be a wide cylinder or a tall, skinny cylinder. We're not really sure what type of, there's many different cylinders that could fit inside there, but we want the maximum volume, the biggest possible volume. Now already it's got some difficulty to it for sure, okay? We want the volume of the cylinder. The volume of a cylinder is pi r squared, that's a circle, times the height to make it into a cylinder. We want to take the derivative of this. If we take the derivative of this, we'll be good. Now, I don't really know too much about the sphere helping us out. I mean, the volume of the sphere, I'm not so sure. We don't know much about the surface area. We don't really have much else to go on, but we do have this 6. And this is reminding me a little bit of that question with the paper and the 12 and the 12-foot cardboard piece of thing, which is ridiculous, but whatever. How can we take this 6 and talk about R's and H's with this 6? If we think about a sphere and we're trying to make a cylinder as big as possible within that sphere, we're pretty sure that that cylinder in the sphere is going to be touching the sphere, right? It's not going to be a small little one in the middle because you just make it bigger. And you make it bigger until it touched, okay? And so here's where we're getting difficult. Our circle, which has a radius of 6, our cylinder is gonna kind of make that shape, and it's gonna use this 6 in a little bit of an obtuse kind of way, because we know that 6 is important there. Our cylinder, which is going to be touching the edge, maybe we could use this 6 radius and think of it kind of like a triangle, okay? If we think of it kind of like a triangle, the triangle has 6 as the hypotenuse. We don't know for sure if these two sides are the same, for example, because maybe it's a long, skinny cylinder, or maybe it's a tall, skinny cylinder. So we don't know for sure if these are the same. But if we maybe call this one X, the volume of our cylinder, the radius of our cylinder, not of the sphere, but of the cylinder, would be 2 X's. Or we could say the other way around. Maybe we could say this one was X, which is this piece here, and then the height of our cylinder would be 2 X's, 2 of those. So we kind of have 2 options here. We can say, we can either work with the radiuses, we can work with, I'm thinking, we need to set this up. I know that over here, one of these is squared, one of these is not. I'm not really too worried about squares because I can just FOIL it. So I'm not gonna try to mastermind this too much. Let's say that X is this. Okay, let's just leave it how it is like that. Okay. First of all, that allows us to say that our H is 2X. Right, our H would be another one of these. It would be 2X. Now our radius, if we just leave it as radius, we still have the problem of having 2 variables here. So let's try to figure out what the radius would be. And we know this is a right triangle. I don't really know what this is. Let's try to go for a little Pythagorean theorem here. Okay? We've got a triangle. We've got 6. We've got X. We know it should be 6 squared equals X squared. And this, that's the radius. It's the radius of our cylinder. So we can just leave that as R plus R squared. And this, we can try to solve for R. Subtract the X squared. 36 minus x squared equals r squared. Square root both sides. Okay, a little gross, but we've made progress here. R can be expressed as the square root of 36 minus x squared. Square root 36 minus x squared squared. Alright, we've gone a little crazy for this question. Like I said, this is definitely ramping up the difficulty. We use this 6 to think about a triangle that was half of our height and a radius. We used x. We could have used like 1/2 h, but that would have been really confusing. So we just used x. And then we did the Pythagorean theorem, and we found r, and now we have only one variable here. That's really nice. Let's try to simplify this so that we can hopefully use just a nice power rule. I'm thinking, ew, I have that squared, which means I probably have to FOIL. But then, this question kind of has a nice little beauty to it at the end. Because if I write this a little bigger, because I know I got a little bit messy. Square root 36 minus x squared, there's 2x. If I try to FOIL that thing, because it's square, I actually don't have to, because square root, squared. Those two things are opposites. So those two things are gonna pi times 36 minus x squared times 2x. I don't need to FOIL anything. I just need to distribute. I kind of need to distribute pi and distribute a 2x. I want to be done with this question, so we're going to do it in one step. We're going to take 36 multiplied by pi and multiplied by 2x. So that's going to be 72 pi x. 36 times 2 times pi times x. I'm going to take my negative x squared and I'm going to times it by 2x and pi. That's going to be negative 2 pi x cubed. Volume is equal to 72 pi, or sorry, d volume dx is equal to 72 pi minus 6 pi x squared is equal to 0. I only have one x term here, so this should be easy. Just move stuff around. I'm going to add that to the side. 72 pi equals 6 pi x squared. I'm going to divide by 6 pi. Obviously the pi's are going to go away and cancel out. 72 divided by 6 is 12. 12 equals x squared. And then square root both sides. X equals the square root of 12. Alright. Now this question, on one hand, is completely ridiculous. What the heck are we doing? Trying to fit a cylinder into a sphere. At the same time, maybe you're doing some weird fancy thing where you're trying to build a machine, I don't know. But for sure, if you had to guess, and you had 1 million guesses, that is a strange number to maximize it. And even with 1 million guesses, you might not be able to guess that x value. Now that x value is, it's not the radius and it's not the height. So that x value, we're gonna have to use to go backwards and find the height and backwards to find the radius. So let's do that work before we finish here. Another way that we could write this also, because square root of 12 can be simplified, would be 2 square root of 3. Just in case it wants that. Okay, the height. We said that the height would be 2 x's. So our height would be 2 times that. I'll say 4 square root of 3. 2 times 2, which makes 4 square root of 3. That's an easy one. We knew that our height was just double whatever that x value was. The radius is a little bit more complicated. I would probably want to go back here to find the radius. I would probably leave it in the square root of 12 form here because it's going to be squared, and that's going to just kind of make that nice. So the radius equals square root 36 minus square root 12 squared. And the square root of 12 squared is 12. 36 minus 12. Square root 24. Are there any perfect squares in there? Yeah, maybe 4 times 6, so r is equal to 2 square root of 6. We're still not quite done. It says, what is the maximum volume? So use these numbers and get them in there. Please, I just want to be done here. Volume is equal to pi r squared. I'll probably do the 24 since I know it's going to get squared times h. Volume is equal to square root 24 squared is just 24 times pi is 24 pi times 4 is going to be 96. 96 pi square root 3. So, ridiculous question. That is a question, that is an answer that is just unimaginable, really. I guess if we wanted to be really good, we would be cute. We're finished with this piece of paper. On a test, I'm not going to give you a question that's this hard, but while we were doing questions, I figured let's just see the length that as far as we can push something like optimization. I don't know why you would ever want to do this, but if there was, 1,000 people who were all offering their best possible answers and they were just guessing, I don't think anybody is guessing these values. And so if you can actually calculate it, you can be better than all 1,000 of those people. All right. Nice job. Those are optimization practice.